Hi everyone and welcome to the Microsoft Power BI UK user group. I'm your host Leon Gordon and I'm here with my co-host Pragati Jain.
Hey everyone, welcome to us today's session.
Excellent. How's your day been so far, Pragati?
Yeah, it was a bit busy, but yeah, it's always good to end the day, right? So now I'm fine. How about
Exactly.
yourself?
Oh, very much the same. Unfortunately, my day doesn't end yet. I've actually got some stateside meetings after today's session.
After, oh,
Um,
that looks scary to me right now. I hate evening meetings. Come on.
exactly. But I'm happy to be here with what is going to be a very interesting and I'm sure widely appreciated session today.
Definitely, I think I'm very much looking forward to today's session because this is kind of a hot topic, and let's see what Rishi has got to show us today.
Oh, definitely. And thank you everybody for coming along and joining us today. As always, please do let us know where you're joining us from. How's your weather been where you are? I know it's summer, or supposed to be summer. Unfortunately, the UK can't really handle the summer, so we get a lot of rain as well. So let us know where you're dialing in from and how your day's been so far today. So with that being said, as always, we want this to be a very interactive session. So please do feel free to ask questions throughout. Today's session, like we said, is going to be on querying large data sets at scale with Power BI and Synapse. Now, we're looking at, I believe, it's billions of records worth of data being queried and presented back to us in Power BI. And I, for one, really like the NYC taxi data set, so really interested to see how this session pans out. So with that being said, I'll introduce today's speaker. Now, today's speaker is Rishi Sapra, who's a fellow Microsoft MVP. He's also a fast-track recognized solutions architect and Microsoft certified trainer who specializes in advising enterprise clients on self-service business intelligence and building reporting centers of excellence. Rishi, welcome. Thank you for joining us.
Hey Leon, hey Pragati.
Hey Rishi, welcome.
Thank you.
Absolute pleasure to have you with us today.
Thank you for having me back. It was actually a year ago I was on. I think almost exactly to the day. A year ago, I was last on the UK Power BI user group.
I'd love to say we planned it.
Let's make it. And let's make it twice a year rather than once a year, though. How about that?
Oh, definitely.
I think definitely we would love to have you back, Rishi.
Brilliant.
Like I say, I know that we have everybody's very excited for today's session, myself and Pragati included. So what we'll do, Rishi, we won't hesitate, but we'll hand over to you for the session.
Thank you very much. You can all hear me fine, see the screen. Everything's good.
Yes, we can see your screen. Yeah.
Brilliant. Perfect. All right, thanks. So yeah, just Leon's already given an introduction, but I'm the MVP. I'm also a chartered accountant by background. Actually from a kind of non-technical background. I went to LSE and then worked for Big Four Consulting and some of the banks in central London, and then moved over to Altius in 2017 and been working on the Power BI stack ever since then. And we got acquired by Avanade in 2020. So I run two main communities at the moment. One is called Learn Data Insights, which is all about quizzes and courses to help people prepare for Microsoft exams and to do learning in things like Power BI, Power Platform, Azure. And the other one is Power Platform Finance. Given I'm an accountant, I'm really focusing on accountants and helping finance teams move into the modern Microsoft technology stack. I'll put the links to both of them in the chat. If anyone wants to check them out, then please let me know and let me know if any questions. So what we're going to look at today is, as Leon said, working with 2.3 billion rows of data in New York City taxi data. And actually what I'll do, let me just show some of the data. So the source data is coming from here. So we've got a SQL data warehouse, Azure SQL data warehouse. That's got the record counts on there. We can see is 2.4 billion rows. And if we just have a look at what some of that fact data looks like, we can see its dates, the medallion, Hackney license ID, pickup time ID, so when and pickup geography, and geography relates to things like weather and things like that, and longitude and latitude. Passenger counts, how many passengers were on that trip, how long was the trip in seconds, what's the trip miles, and so on. And then we've got a few different amounts and fare amounts and tip amounts and things like that. So lots and lots of data. Not atypical to what you'd find in a large organization. So this is what I really wanted to show, how we can deal with this with Synapse and Power BI. So there's 4 key steps to doing this. The first is start with the end in mind. And with this, it's all about being able to understand what type of insights you need to deliver. You're not going to be able to show 2.4 billion rows on a visual. There's no point trying. It's impossible to visualize that volume of data. So you really need to think about what it is that you do want to show and what level of granularity you need that at. And that's going to define the blueprint for what you need to do in Azure or in Power BI to be able to shape your data to get the right tables. So the next point is then get Azure to do the heavy lifting. Rather than just trying to bring 2.4 billion rows into Power BI, which is a self-service tool, Azure is meant for dealing with data at scale. So it's got things like Synapse pipelines, Azure Data Factory, essentially, and then notebooks and Azure Data Lake, obviously. So we're going to look at how we could use those technologies to be able to work with our volumes of data and shape it, rather than just using Power Query. The third one is to actually leverage the enterprise tooling in Power BI. So Power BI is an enterprise tool, and it's very much an enterprise tool in terms of the data model, and in terms of how you can manage those large scale data sets using Power BI. And we're going to look at aggregations, which is where within a single model, we combine DirectQuery and Import mode into the same table. And the last step is to curate the user journeys. This is a nice fun part at the end. This is the data visualization, but it's really, really important. So once we've got our model and we've defined the grain and we've shaped our data how we need, then we need to think about how to tell that story with that data and curate those user journeys that our users need. So let's start with the first one, which is start with the end in mind. Now, looking at this is all about actually understanding what your users need from a report. And this is obviously a community example, but I did a bit of Google searching about New York City taxis. And it turns out that in 2013, it cost $1.3 million to get a medallion in order to operate a New York City taxi, which is crazy. So since Uber and Lyft have come about, since then, it's dropped massively to 160K. But then 160K is still a lot of money. If you were someone looking to potentially purchase a medallion, you'd want to know when you're going to get your money back. You'd want to know how profitable is it driving a New York City taxi. And historical data on trips is a really good way to be able to do that. So actually, this is our audience for our reporting. It's people who are looking to purchase a medallion potentially and figure out, is it worth it? So one of the things I always do once is firstly identify the audience, and that's always the first thing you need to do with a Power BI report. It's not data, it's people. The report is for people. So identify who those people are, and then think about those questions that you need your report to answer, that this audience are interested in. What are their problem statements? So for here, it'll be examples like how many trips are done on average each day? What time of day is it best to take trips? Does it make a difference if it's raining or if it's hot? Does that impact how much money I can earn from being a taxi driver? And does it make a difference what area I operate in? Because these are choices. I can choose to sleep certain hours and work certain hours. So actually, these are real choices that are going to impact my decision. Then you think about the KPIs and measures that would help to answer those questions. So things like number of trips, average fare amount, and what would you want to view and filter those by in order to be able to answer those questions? So location, trip duration, pickup, whether you have single or multiple passengers. Those are your kind of attributes that we want to then look at. Now, if you're from a technical background, you'll think about these in terms of facts and dimensions, but this is a completely non-technical exercise and one that should be done with business users, with your end users of your report. Really find out in those requirement gathering sessions. Forget about asking them if they want a line chart or a bar chart, or they'll just point you to a report they had before in Excel and say, could you do this for me? Actually focus on the business questions that they need to answer from it. And so just looking at this, this is our assumed pain points. The audience needs insights over the data. We can't just give them a table with 2.4 billion rows. Even if we gave them 100 tables, each with a month's worth of data, it's not going to mean anything to them. We need to be able to get insights from it rather than just individual trips. And it's obviously a lot of data to consume, too much in Excel, obviously. And even in Power BI, if you try and bring it into import mode, your data refreshes will be very, very slow, and the model might be quite slow. And then also trying to retrieve data on the fly with DirectQuery is also going to be very slow with that volume of data. And if you've got a really, really ramped up data source, potentially it might be okay, but even then you need to be very careful working with DirectQuery. So, and I see this again with lots of clients that I work with, We can build data models, and working with small volume of data is easy, but once we want to scale it, that's where the real challenges come. So the next step, once you've identified the user audience, is to really think about the data points that you're working with. Which of them are relevant? What do they mean? Right? Rather than just looking at it and saying, yep, I know what that is, actually document it. This documentation will come in handy. Once you come to document your model, especially if it's a shared data set, you're going to need some documentation anyway. And I find from a consulting point of view, it actually really helps to bring you on the same page as the client, because then you're looking at the same thing. You're referring to specific fields which have been documented. And think about whether you need to use those in reporting. And then probably comes one of the most important parts, which is then this idea of a bus matrix. And this is my own version of a bus matrix. But what you do with this is you essentially draw up your rows, your measures along the top, your numerical values essentially. And then on the left, or the other way around, sometimes in the bus matrix, you pick out what attributes you have those numerical values by, what grain. So here we have it by year, month, and date. We have it by time and time bucket. So, 10:30 in the morning. We have it by individual longitude and latitude. We have it by the number of inches in rain. We have it by the number of degrees and temperature that it was at that time of the pickup or drop off. We have the license number, we have the number of passengers, and we have the chip duration bucket. Now, then you could take, once you've got it laid out like this, and we've got all of these ticks here to say that this is the data that we've got it by. And sometimes actually, if you're working with different fact tables, they'll have different granularities. So then you can work out what your common granularity is. So that's really, really useful when you're working with numerical data that's at different granularities. But here it's all the same granularity, but even here it's really useful exercise to do, because now we can look at this and say, actually, how useful is this level of detail for our reporting? And once we start to take a critical look at this, we can start to say, well, actually, does it really make a difference whether it was 63 degrees Fahrenheit or 65 degrees Fahrenheit? No, it doesn't. It probably you just want to know whether it's hot or whether it's cold, and whether that makes a difference to your trips fare. So actually, rather than having degrees temperature, we can actually just categorize that as warm, cold, very cool. Same with longitude and latitude. We actually don't need that. We've got country zip codes. That's probably enough that we need to look at. Even date, do we need to look at, if you're looking at 13 years of data in this case, do you need to look at it day by day? Potentially at some point, but at least not for your main views. Monthly is probably good enough for that. And same with time bucket. Does it make a difference if it's 10:30 or 10:45? No, probably not. You just want to know, is it better to pick up people in the morning rush hour? Is it better to pick up people in the evening? Those kind of things. So what we could do is start to then define our granularity at a much more sensible level. So by month, by rain category, by temperature category, and by passenger count category, whether it's single or multiple passengers, just that single flag. And this takes our data from 2.4 billion down to 1.8 million, which is much more manageable. In a Power BI data model, that's going to be much, much faster. And it's also much more useful, because now we're looking at data that makes sense in terms of our categorizations. And I've done it also just for the pickups. I don't, we only need one data point per trip. And then what we can do is turn that into star nets. And this is your conceptual model. This is your view of what your data model is going to look like. And it's your blueprint for what tables you need to get to as your end result, whether you're doing it in Power BI or whether you're doing it in Azure. So we start with our numerical values in the middle, and then coming off those as branches is our dimensions, our entities, attribute entities. And then within those, you've got attributes themselves. Now, even though I've talked about facts and dimensions, actually, this is, again, a completely non-technical exercise, and something you can and should do with non-technical users, because it helps you to visualize what your data is going to look like. And you can, before you even start building anything, before you even open Power BI, you can know whether your data model is going to support those questions. You can say, right, I've got a question on what time of day is it best to take trips. Yep, I can answer that from there because I've got this pickup time bucket and I know the number of trips on there and the fair amount for those. So you can really look and see and validate your data before you start building stuff. Any questions on that section, Leon or Pragati?
Yes, there are indeed. So first and foremost, really fantastic run through. Our first question comes in from Anthony Catella, and they ask, what cost implications are there using these tools for this number of records?
Well, let's come to that when we look at Azure. So for doing this documentation, you asking me how much I charge clients? Well, no. There's no direct cost to Microsoft being paid for doing the documentation and just stating in the requirements now. But when we come to Azure, we'll talk about cost then.
Excellent. And Pragati, do you have the next question?
Yeah, so the next question we have got from Zenu. Sorry if I'm mispronouncing your name. So Rishi, you remember you had a slide where you have split the, you had a table, right, where you had your facts and dimensions and the kind of measures you need. So he's asking a question, what tool did you use to generate this documentation before report development?
Word and Excel.
And I think there's another slide I think he asked about.
That's Word. That's a Word table. That's
this one. Yeah.
Excel, maybe. Again, Excel, I think, or Word, either one. I can't remember. And you can use Visio for this, or Draw.io or something like that. I can't remember. I think this was again Word, right? You've got shapes in Word as well.
Yeah.
I don't overcomplicate it.
Excellent. And then final question for this section via Swanand. Hopefully I pronounced that correctly. It says on one of a couple of slides previous to this, Rishi, where you've looked at all of the attributes and then negated some of them. They mentioned that you may need a trip count by the time where you had a X mark. So maybe it's just an example.
So we don't need it by time, right? We don't need to know that it was exactly 10:33 at the time of pickup, right? We just need to know, was it early morning? Was it lunchtime? Was it evening rush hour? That's what we need to know. So that's why we've got a tick against time bucket and a cross against the granularity of time. So even though these might be, these are the same, this is the same data, it's at a different granularity. So we want it at a higher grade. We don't need the lower grade data.
Fantastic. Thank you for clearing up for us, Rishi. No more questions for now.
Right. All right. So now we want to get Azure to do the heavy lifting. And here, what we really want to do is use some of the Azure technology. But what I want to do before I jump into their portal, which I will do, I just want to go through a couple of slides to set the scene and the context for what we're building using Azure. So we're using Azure Synapse Analytics. And I think there's a lot of confusion, actually. What is Synapse? I get that question, actually, quite a bit of times when I talk about Synapse. And so the idea is it's not just a single product. It's actually a combination of multiple different things. So it brings in things like pipelines, which is essentially Azure Data Factory. And then it brings in notebooks, which is, you could write Scala or SQL or Python to be able to query your data using the Spark engine, which is, again, like Databricks does. So it has a lot of that Databricks style technology within Synapse as well. And it also has data warehousing capability, because actually that was ultimately the original starting point of Synapse was just Azure SQL Data Warehouse. So it brings all of that together, and actually it brings it together in a very clever way, because essentially you can have an Azure Data Lake, obviously is one of the main things. It allows you to combine those together. So you can combine SQL with Data Lake and can query your Data Lake data using serverless. So just to cover what those are, so we've got dedicated SQL, which is SQL DW. You've got serverless SQL, which is essentially querying files stored on Azure Data Lake as if they were in a database. So you can write SQL against them. And actually, you don't need to then move your data from a storage layer into a database or into somewhere else. As soon as they're in the storage layer, as soon as you pick them up and landed them in Data Lake from wherever you're getting them from, they can be queried straight away. So no need for those ETL processes, essentially. You've then got the Spark pool. And the Spark pool is really for running notebooks and mapping data flows, also runs on Spark. And this is where you're using the Spark technology, that open source technology, which is very powerful to be able to run a multi-cluster environment, essentially to be able to run big data volumes. So it's used a lot for machine learning, where you're running hefty models, and also big data engineering tasks. So something we use for, you could use this in Databricks, for example, in Azure, but you could also use it in Synapse. And Data Explorer is for custom queries. So it's where you've got logs. So for those of you who might be aware, there's also log analytics in Power BI, for example, that stores it in log analytics, and you can query that using custom. Then you have pipelines, said Azure Data Factory. So it's doing your ETL at scale. And Power BI, you can connect Power BI directly to Synapse. You can actually create Power BI within Synapse Studio. create datasets and reports within Synapse Studio. And then you've got Synapse Studio itself, which is your platform for developing SQL pipelines and notebooks. If you recognize this slide, it's from Andy. So thank you, Andy, for letting me borrow your slide to explain this. And then we look at creating an Azure Synapse analytics workspace. So the main thing this does is just give you a data lake, a built-in data lake into Synapse Studio. And that data lake is automatically connected to a built-in SQL endpoint. So you can just connect to that data using the SQL endpoint. And that's the main thing just setting up a Synapse Analytics workspace will give you. You can then add other things and other aspects of it. So it's part of provisioning it, a new SQL Serverless pool is automatically created. So serverless pools, so it's external data. So we've got things like databases. We can actually treat it exactly, even though the data is still just sitting on data lake, we can treat it as if it was sitting in SQL. So we can create a database, create an external table from it and say, I actually want a table with columns that I can query as if they were just columns, but I want it to point to those files on data lake. And all the rest of the things as well. And so everything can kind of read into Synapse Serverless. So Dataverse, Cosmos, Azure Storage, and obviously the main one being Azure Data Lake Gen 2, which is ultimately the foundation layer behind these. So even Dataverse and things like that, to go to put into Synapse, you go through Data Lake Gen 2, really. So, and it can write back to those as well. Anthony was asking about costs. So you pay for serverless just by the volume of data. You don't pay for the 2.4 billion rows worth of storage. That's not what you pay for with Synapse. You pay for that with Data Lake, but storage is cheap. For Synapse itself, it's $5 per terabyte processed. So actually, that's pretty good. That's pretty cheap. And you don't need to worry about capacities running and forgetting to switch things off and things like that. It's just always on. You never need to stop it. It's just when you use it, that's when you pay. It's a much better model than some of the other kind of PaaS services where you can get charged a lot of money unless you have the right timeouts. Resources are allocated automatically, but bear in mind it's not a massively fast database engine. And then I wanted to just talk briefly as well about the idea of a lake house. Now, the idea of Delta Lake, and I'm sure some of you would have heard about that, is that it brings together data lake technology with essentially data warehouse technology and structures and architecture. So data lake, as I'm sure you're aware, is a storage place. So you can put anything in there. And this is why data lake's been useful, because typically in SQL, you've only really been able to just store data stored as rows and columns. But actually, what about if you have JSON files, XML, and all of these other different images, videos, all of these other types of data that you want to be able to analyze, then you can actually put those into data lake. And so it's much more flexible. You don't need to define this really rigid schema for it. You can define that schema when you query it. So when you do from Open Row Set from your data lake, then you can define the schema there. So Delta Lake takes that data lake technology and says, well, actually, the benefits of data warehousing is that you do have a schema and it's defined, and that schema is enforced. So you can't just write junk to it. You actually have to write stuff that works with that schema. And the other benefit of a data warehouse is that you've got all of these insert, write operations that you can do at a transactional level. So you've got that transactional rigor, which you don't just have with files. So what Delta Lake does is combine those two together. So it gives you those transactions, but you also have Spark being used essentially to be able to have those read-write operations. And to give you an example, like for example, it will merge data together. So Data Lake, I can chuck as many files in there as I want. When I bring them into Delta Lake, it will just give me the unique values, the latest record for each. And I can actually go back and see what those records were by this concept of time travel. So schema enforcement and connection support. So it's stored in Parquet files, and Parquet actually is schema aware. So it recognizes the schema, data structures of those files. And Lakehouse Architecture. So essentially what we do is we have different Delta Lakes or data lakes. We have 3 layers of our data. The first is raw, and this is where all of our data is untouched and just put into a lakehouse or into Delta Lake or data lake. And that's your bronze layer. We then have cleansed, which is your silver layer. This is where you take the raw data, and if you ever need to go back and use this for other purposes, then it's there. Here, it's the raw data, but with cleaning applied. So, most people would probably use this or the gold layer, obviously, rather than the bronze, but you need to want to have that there anyway. You want to have a copy of your original data as it landed. We then have the cleanse data. So this is then applying any transformation, cleaning steps to it. And then you have your gold. And this is really what your data warehouse would look like. It's essentially your fact dimension tables, but they're sitting in a Delta Lake or a data lake. So that's essentially your 3 layers that we're going to go through. And then we're going to look at serverless pools to query that and put it into Power BI. So let me now switch over to Azure. And here I've got my Synapse Studio. So once we start, we can start with the Integrate tab. So here we have our pipelines. Now, what I'm doing in here is, you recognize this as looking exactly like Data Factory. Essentially it is. I'm building a pipeline, just a copy activity. So I'm doing a copy activity to say, take my data from this Azure SQL database that I showed at the beginning and copy it out into Data Lake. Not Delta Lake, just standard Data Lake, Azure Data Lake Gen 2. So standard copy activity, but what I'm doing here is saying, actually, rather than creating 10 copy activities, one for each table that I've got in my database, I can just do it for each. So I've defined here a parameter, tables, and it's got their date, geography, time, weather. And then it does for each of those, it does the copy activity. So you can see in here, all it is for each is just a copy activity. The source is the NYC taxi database. The table is the name of the table is item, i.e. what it's doing it for each for in that parameter. It's just an array. And then the sync is just going to be Parquet files on New York City taxi. And if we look at that, we can see that it's writing it into a folder called bronze prod raw. So bronze layer, bronze folder, actually it's just a folder, giving it then a folder name so it's partitioning it by the table, and then it's partitioning it by the date stamp. And what I will do is I'll actually show you what that looks like in Storage Explorer in a minute. And then what we're doing, so we're doing that for all of our, and we're setting the timestamp. So this is just the current time. So actually that's just a variable timestamp. The value is just now. Yeah, set the timestamp to the value as now. That's all it's doing, UTC now. So this is a variable we're going to use later on. So now if we actually look at our data in, just bear me a second. So now if we look at this in as a Storage Explorer, so these are the folders I created, bronze, silver, gold. So if we look at, say, our bronze layer, let's put it into, and we look at raw, and then it's going to put it into, for each dimension table that we've got there, so say geography, it does it by the timestamp of when I actually ran this pipeline. So I've run it once or twice in June and once or twice in July. Last time was 4th of July. I ran it 3 different times. So when I ran it, this is the one I uploaded, ran at 1932. So I've got all of those still just stored there under the different times when I ran the pipeline. So that's my geography file, which was as of 1932 on the 4th of July. And now for the fact table, I could have obviously just included a fact table as one of my tables in the parameters, but that's 2.4 billion rows of data. And what it will do by default is just try and put that into one massive Parquet file. And that's just not optimal. I don't actually think it works. I think it timed out. So what I did here was just say, actually, give me the set of dates from my query there. And so just select distinct date, group by date ID. I didn't even do that, it's distinct. Anyway, and then pass that into the query for my copy activity. So for each date, it then runs this activity. And then the source is essentially the query that says select from the fact table where the date ID is your item date ID. And then your sync, very similar, but this time it's actually writing it not just by the timestamp, but also actually by the year, the month, and the day of the actual date, the actual trip date. So now if we look in here, we can see bronze prod raw trip data. And again, first is timestamp. So when I ran it, 4th of July again. But now it's broken down. I only ran this for 1 year, but it's broken down by year, by month, and then by day. We can see that now each day is its own Parquet file with about 20 megabytes. It's about 500,000 rows in each file each day, number of trips each day. So that works quite well. And now we've got a nicely partitioned structure for our data and data lake. Now, what we then did is then once we've run that, we then have this idea of notebooks. Now, the notebook is basically for me to turn the data that sits in data lake and put it into Delta Lake. So what I'm doing is applying this layer on top of data lake, because all I've written to here on copy activity is just standard data lake. I'm now using the notebook to turn that into Delta Lake. So notebooks, and I've got two create Delta Lake tables, one for the dimensions, one for the facts. So actually starts off with a timestamp and table name, and this will actually be taken from the pipeline. So it doesn't make a difference here. I need to actually comment those out. Then what it does, and this is written in Scala, and shout out to Ryan Bayasaki, who works with Mike Carlo in the US, if any of you know him, and he's helped me with this in the past for LDI. So I've just copied these and used the same code, literally, even though it's completely different data, the same code just applies. So you can really reuse it once you've got it once. So what this does is just Spark SQL, create table. So create your Delta Lake table with the database and the table name. So the table name is going to be your table name in your lake database that's creating. Read the data from data lake by the timestamp, and then write it to a bronze and silver layer. So when it writes it to a bronze database, there's two databases, one bronze, one silver. It does mode append, because we want our bronze to just be all history. So if we've uploaded, 2 million files 10 times, we're going to end up with 12 million rows, right? And then with silver, we actually want to just get the latest one for each day. But a raw one, it just does delta mode.append, and it just writes it to that lake database. And then the silver, it does it with mode overwrite. So in this case, it's going to merge. So it's essentially exactly the same thing. It's just say read it from there, but this time do an overwrite and do it as Delta Lake with a merged version. And then we actually go to data, we can actually see those databases there as well. We can see the lake database, we've got bronze prod, and we've got our tables there. And this is then tables. And these tables can just be queried exactly as normal tables. They're just Delta tables, Delta Lake tables. So we can select the top 100 rows from any of them or do what we want to in there. So we've got a lake database. And this is distinct from a SQL database. And I'll show you actually, we have a SQL database as well when we come to later. So now if I just go back to Synapse, and if I look at the gold layer, so now we've got our bronze and our silver. And then for the gold layer, what I've done is essentially used mapping data flows. So what I wanted for the gold layer is to apply some transformations to give me my facts and dimensions in the way that I want them. For our aggregated table, essentially, the 1.8 million row table, I want to create that in the gold layer. And I don't have the programming skills to be able to do that in notebooks. So what I've done is actually done them using mapping data flows. So here, if we see here, we've got mapping data flow, and it just takes Delta Lakes. So here you can do it using a UI. And this is for me, one of the major advantages of Synapse over, say, something like Databricks. Databricks is very, very code heavy. With Synapse, you do have other options. So like this, for example, I created this without writing any code. So my source for it is then the workspace DB, because it's a lake database. So it's now gets picked up in here as a lake database, silver database. I'm taking the trip data column. And the first thing I'm doing is actually just projecting the data into the future, because this data was actually from 2000 to 2013. I actually just wanted to imagine if it was 9 years later, so that I could have real data for 2022 and use things like incremental refresh and things like that. So I'm just creating some columns, and I'm saying date ID is date ID plus 90,000. The year, then the month, and the day of those on there. And I'm putting in the same for some other tables, geography, weather, and I'm projecting the data in the weather table. And then I'm joining them. So I'm joining this New York City taxi data with all of these other ones. So it does joins like you do joins in SQL, but I want to get all those columns from those other tables because these ones contain, the weather, the rain in inches and the temperature in degrees is coming from this table, and the time itself is coming from this table. So now what I wanted to do, if you remember from the beginning, we looked at those categorizations. So what I'm doing here is then adding the category columns. So I'm saying, okay, what the passenger count category is just very simple. If your passenger count is 1, then it's single. Otherwise, it's multiple. And you can't have 0. Raining category, very, very simple. If the inches is greater than 1, then it's heavy. Otherwise it's between 0 and 1, it's light. Otherwise it's not raining. And temperature, similar kind of thing. Kind of had to Google a bit about what Fahrenheit kind of means. But essentially Fahrenheit greater than 90, very hot, hot, warm, cool, cold. So now it's just simple case statements that gives us our category columns at the end. And then I'm doing 2 things with that. Number 1, I'm adding those to my trip data, to my 2.4 billion rows, and writing that out to a sink. Because actually I want my raw data with these category columns added, because I need these category columns in there. And then I'm also grouping by the category columns, so we can get to our aggregated table, and that gives us our ag table. And here I'm actually just writing to, I'm not actually writing to Delta Lake, I'm actually just writing to standard data lake, because actually the curated layer, that's good enough for me. I've got my transactional history, I've got everything I've done in my cleaning steps. If I ever need to go back on stuff, here I just need it in data lake to be able to link to. The last thing I can do there is go into linked databases. Now here what I can do is actually create, so I can query this data. So actually if I look at Azure Data Lake and I look at Gold Trip Ag here, we can see I can actually go in and query this. So I could go in and query Trips Ag, and I can say, actually I don't need to do that, I just need to do this, use SQL script. I can just select rows, tell it it's Parquet format, and it will give me an open row set table. So using the open row set, I can just query it. I can also write views and things like that to get the data, and then I can see those views when I connect to it from Power BI. The other thing I can do is actually just say, I just want to reference this as a table, as if it was just a table. And it's like a thin table, so it's not really moving the data into SQL. It's still just a SQL layer, cache layer essentially over the top of Data Lake. But I can select here the database. So if I do new SQL database, give it a name, then I've got that data in my SQL database. I'm not quite sure where it is actually. There was a tab here for a SQL database. I'm sure I did create one, but I'll show you in a minute where that looks like. Let me just quickly return back to slides. I've just quickly summarized where those things are. So setting up the Synapse pipeline, we've got separate strands for dimension and looping through the fact table, putting each data into a separate file. We've got the notebooks. The bronze notebook script just has a raw dump. It just appends. And then the silver one uses the overwrite function to be able to have the latest file for each date. The mapping data flow reads from that silver data lake, applies the transformations, and writes it to a data lake folder, which is called gold. We're outputting both the raw trip data and the aggregated data. And then finally, we're creating a SQL database, so distinct from a lake database. I mean, they're both databases, but one's just SQL, one's in Delta format, and creating the external tables or maybe views to expose data in that SQL database that we've just created. It's just a serverless SQL database. So again, it's no dedicated hardware, nothing like that. It's just give me a SQL serverless database. It's just a view of my data over Data Lake. Cool. Any questions on that? So I know that was quite a lot there.
No problem at all, Rishi. I'm sure you expected there to be quite a few questions, and there is. So we'll start off, and the first one coming in is from Swanand, and it's actually a continuation of their previous question in terms of when you were removing the count by time. How do you deal with the detail rows?
With detail rows? Do you mean like in terms of Excel analysis detail rows? I think let me come to that one, because when we see the aggregations, I think it'll make a bit more sense. So I removed it from my aggregate table. In my raw table, it's still there, right? In my raw table, it still has a time ID in the fact table. It's in my detail table. So I've got two tables now that I've outputted into my gold layer. One is aggregated, it's 1.8 million rows, and that has it just by time bucket. So early morning, evening, whatever it is. Doesn't have it by individual time. My detailed one, the 2.4 billion rows, has those time buckets and all those other categories as additional columns, but it also has the individual detail. It has a time ID, which links to 10:37 in the morning, whatever it is. So I've got two levels of detail, and we're going to use both. We're going to use both of them.
Perfect, thank you. And Pragati, do you want to go into the next question?
Yeah, so the next question is from Louis, I think. Sorry if I'm mispronouncing your name. In any case, is it right that first point is to reduce dataset by adding correct filtering at SQL?
Is it? So can you say that again?
Is it right that at first point, it is to reduce dataset by adding correct filtering at SQL?
Yeah, I mean, the first point is actually working out what grain you need for your data, right? So what level does it make sense to display this data at? When you're working with 2.4 billion rows, as I said, you can't display that. You try putting 2.4 billion rows in a map and it's just not going to work. So you need to think about, well, actually, what do I want to group this by? I want to group it by county or state or zip. Again, what kind of categories and aggregations make sense for the data that I'm looking at? Obviously, then you want the ability to people to go drill down into individual trips, right, and see the individual trips that make up all of those. But you can see that an average of $10 was made, in this month when it was raining in this state, and then you can go in and say, okay, actually, this looks really interesting. I want to see the breakdown of those individual trips.
Yeah, exactly. And Rishiba as well goes on to say they have a comment as well which says a similar thing. Definitely recommend doing so, trimming down the data as much as possible before bringing it down into Power BI. The next question comes from Zenu.
I'm just a bit conscious of time, Leon. I'm just wondering, is it better to take questions, or I will run out of time otherwise?
That's fine. Let's just have this one and then we'll move back on. Okay, so this question is this a data stack as a service?
Data stack as a service. I don't know, Leon, do you have a view on that one? I don't know. I haven't come across the term specifically data stack as a service. It's Delta Lake, which is an ability for you to have different layers in your database, and that's the architecture that you use. I haven't come across the term data stack as a service before.
Yeah, I mean, I'd probably say depends how it's being defined. But in simple terms, obviously, the Azure-based data platform, which Rishi is showing us today, itself is an end-to-end, what I would call a data stack, which is provided to you as an online service. So hopefully that's a roundabout way of answering the question. But if there's any more detail we can have on that, that'd be great.
Cool. Okay, sounds good. Excellent. All right. So let me just now move on to the third section. So we've looked at the first, we'll start with the end in mind, design your conceptual model. The second was get Azure to do your heavy lifting. And the third now is look at enterprise tooling in Power BI. So the first one that we're going to look at is aggregations. And this is really key to what we're doing and why we've done two levels of data, why we've got two fact tables, essentially, one at 1.8 million and one at 2.4 billion. Great. So traditionally, there's been two modes to connect data into Power BI. You can import mode, which brings all the data into the Vertipack engine, into the Power BI proprietary analysis services engine that sits behind Power BI. And given that proprietary technology is really good, that data is compressed, that data is optimized for querying. So it's very fast when you query it. When you're doing things like sum measures or counts or any DAX across it, it's fast. It's what it's held in that format and optimized for. But the reason you might not want to do that is if you need real time and you need to just see the data exactly as it is in source, or your data is too big to bring into import mode, or if you need to actually pass back security credentials because everything's at source, that's where you can then utilize DirectQuery. And DirectQuery doesn't bring any data into Power BI; it just stores it where it is in the SQL database or whatever it is. And then every time you go into a visual or every time you click on a slicer or something, it fires off a query to work out what you need on the page, converts your DAX essentially into SQL and fires it off against the SQL database and returns the data. Now, whilst that probably sounds great, in reality, it's very, very hard to get the performance on that because the conversion from DAX to SQL isn't always optimal and often isn't. Power BI is very, very chatty. And then, it has to go against the database. It depends how good your database is to be able to run that query and then pass it back. And you've got the latency. In reality, it's quite hard. So what we're able to take advantage of is the idea that actually it's not one size fits all. You can have an aggregation table in Power BI, which is an import mode and fast. And then you can have a direct query table, which contains your granular leaf level data. And you could use both in the right way. So actually, if you're viewing aggregated data, which is 90% of your time, you're viewing things by time bucket, by rain category, by temperature, by state, all of that stuff can just be dealt with from the import table. If then someone says, potential taxi driver says, they'll actually really want to see exactly what those 100 trips were. I want to see the detail of those 100 trips. They could drill down into a drill through page that shows, the individual trip for those 100 trips, the longitude, latitude, every single detail point. And that leaf level data can be direct query because actually all it is 100 trips. It's just telling 100 rows. You're not bringing 2.4 billion rows trying to aggregate it on the fly in Power BI. So that's where you could use the technology for both of those to their advantage. So this is what we have here. Is, let's say, it's the best of both worlds. You have your aggregation table, which is all of our categories here and our number of trips and average fare. And then you have your detailed table here, your trip data. And then we have our dimension tables connecting to both. So this is like a standard star schema model. So we actually have import mode for your aggregation table, direct query mode for your detail table, and then everything else is actually dual mode. The dimensions are dual. What that means is it can either be import mode and go against the import mode table, or it can be direct query and go against the direct query table. So one of the challenges with this is that all of these tables need to be direct queryable, right? They can't exist in a source. Like you can't have a date table that you create just in Power Query using an M function in normal Power BI desktop, because then it's an import mode table by definition. It can't be a direct query table. And same with, if you use enter data to put in your temperature categories, for example, again, if you use enter data, it becomes import mode. And previously, I've had to do some workarounds by creating some SQL scripts to essentially or SQL queries, so should I say, in order to create these. What I've done now, or you put them into something like Synapse, you load them in as a data source, for example. You can even just use mapping data flows or copy activity, and it will put them into data lake. But you have to do that step. What I'm actually using now to do this is Datamarts, because with Datamarts, you have Power Queries, you have enter data, you can create a date table in there and all the rest of it. And then that data is available via SQL endpoint. So actually, it's kind of really well suited to this kind of aggregations workflow, because you can create your tables in there, and then they store them in SQL. And I think it also has row-level security on there, which again is great, right? If you're doing that direct query against there, or even import mode, you want to make sure that people can see. Maybe you can say actually everyone can see the aggregated data, right? Everyone can see the trips aggregated by time, and aggregated data is generally not as sensitive. As soon as they drill down into the individual grains, that's where you then put some row-level security on your detail table here, and then they can only see the data that's relevant to them. You do have to obviously keep the two in sync to be able to make sure they're not seeing one number and then drill down to another. So data marts are data flows, basically with benefits, I think is the term. So it provides you with row-level security, it provides you with a SQL endpoint, it provides you with a pre-built data set, and you can create relationships measures directly in the Power BI service. And obviously, if we're bringing in 2.4 billion rows into here as well, and there is a reason to do that, because obviously we're now combining it with everything needs to come from the same source. So your import table and your direct query table can't really come from different places unless you've got exactly the same tables in there in both, which we don't. So we need to bring the table in here. But again, this kind of defeats the point, right? We're saying we don't want to bring 2.4 billion rows into Power BI just in one hit. Fine, we're not doing any more transformations or anything there. But what we can do here is use incremental refresh. So we can, because it's a SQL cache, even though it's data lake, it's a SQL cache behind it. So we can specify date and then bring in just the data, the latest data, or even the data that's changed. You can see an example here of where it's actually creating the date from the file path, because we partitioned our files by folders and into dates. What we do then, and I'll just show this very quickly in Power BI Desktop. So the first thing we do is go to Power BI Service. And this is just a view of our Datamarts, by the way. Let me put it onto our screen. This is a view of our Datamarts. So we just brought it in. It looks exactly like a data flow, but it loads it into a Datamart. And then what we can do is go to Settings. And we've got in here our server. So this is basically the SQL endpoint. So we can copy that. And then we go into Power BI Desktop, create a new SQL connection. Don't use the Datamart connection for this because we need to change the storage mode. And we just go to Get Data, SQL, and bring in all of our tables as direct query mode. So just connect to them, bring in every table that we need, including our aggregation table, including our detail table, and our dimensions, bring them all as direct query mode. And then for these ones, again, direct query mode, bring them all in direct query, and I just call them dual, just so I can think about the fact that these are going to be dual dimension tables. And then there's 2 dimension tables which actually only relate to our details fact. So the time ID with exactly what time it is, and the weather ID, exactly what weather it is. The rest of them are actually common. So now we can then go into our data model, and we've got our data here, and we've got, sorry, that was the number one. Number two is dual connections, and I need to put it on my screen. So here, then what we've done is created the relationships we need between those tables. So 2 fact tables, 1 aggregated, 1 detail, and then all your dimension tables connect to both. And then just change the storage mode. So this one now then is import mode, and this one is remains as direct query. So we don't change this one. And then these ones, we go to set them in advanced here, and we set storage mode to dual, which again just means it can be import mode whenever it's being used in import mode. It can be direct query if it's being used in direct query. So that then gives us our data model. We then need to look at aggregations. So aggregations, what we could do is we could just have some measures that only go against this table and some measures that only go against this table. And when we're looking at high-level data, show this, and when we're looking at detailed data, use the other measures. But Power BI is a bit cleverer than that, and it actually allows you to say, okay, if you just tell me that this is an aggregation table and what the aggregations mean, because it doesn't know by default, then you can just write your measures all against this table, but it will do them against this table. So to do that, we just right-click here, manage aggregations. And what we can see here is that we don't need to do anything with the dimension fields because they're just dimension fields. They're common across both anyway. But for our numerical ones, and if I switch into number 3, which actually has that set up already, you can see in here, go to manage aggregations. We have number of trips as a numerical column in our aggregation table, and we can say that's the same as counting the number of rows in the detail table. So it's the same as count table rows, and then this is the same as the sum of that field. This is the same as the sum of that field. This is basically what we did when we aggregated it, when we created the aggregation table. So we're just telling the engine how we aggregated it. And then we can just create a measure that's just sum of trip data fair amount. And then when it's working against the aggregation table, which it will try and do wherever it can because it's much faster, it will use the aggregation table field rather than the data on there. And so we can just create our measures just on here. Count rows, number of trips as count rows on our detailed table, and so on. And actually we can confirm that it is actually hitting the aggregation table. So if we just run a query to say, if this field is common across the aggregation table and the detail table, and we can see here it's got match found. That means it's going against the aggregation table. If instead we did, and the fact that it runs so fast is probably a good giveaway as well, that it's going against input data. And then when we do this, it's then, you can see it's already taking a fair bit longer. And I'm using pickup longitude here, which obviously isn't in our aggregation table. It's just in our detail table. That's then, I don't know why it's taking so long, but that's then going to come back with attempt failed. So just to kind of recap that section. So we create the direct query connections to the Datamart using the SQL endpoint. We change the storage mode for our aggregation table and our dimension tables to dual. We set up the aggregations and the measures, and we just check in DAX Studio that it's actually working all properly and it's handling those aggregations correctly. There is also this idea of auto-aggs, which is basically when you're doing direct query, if you're using the supported source, which I think Datamarts might be, because it has a SQL database, it will start to aggregate those and create caches for you that will speed them up. So if loads of people are looking at the same trips, if everyone's looking at trips in Brooklyn when it's raining in March 2018, then it will start to aggregate that query and return it to you faster. Aggregations are very good. They're a very neat solution. But all of those limitations you had on direct query, on DAX and data modeling, you also still have on there. And it does make your data model more complex. If people aren't familiar with this concept and how it works, you're creating yourself potentially a bit of a maintenance issue. But what you can do and just consider is actually, do you want aggregations, or actually could you just do them as 2 separate reports? Could you just have your detail report that just has your import table, and could you just have your detail table in a separate direct query in a separate report, and then use cross-report draw through or something like that to be able to go from one to the other? It's another option. Cool. Last section. Are there questions, just so I know, and maybe I'll come back to them at the end if that's okay, just in case people need to leave on time.
No problem at all, Rishi. There are questions. Happy to do them at the end.
Sure. All right, thank you. So lastly, we're looking at curating user journeys. so now that we've got our data, we've got our import data, our aggregated data, we've got our detailed data, and now we want to work out the pages where we consume both. So let me just switch again to Power BI. And if we look here, our first page here then is now using essentially all of the fields from our aggregation table. So state, county, time bucket. And we can start to see which time of day is it best to take trips. And this is a really good idea as well, actually. You can see here 2.38 billion trips in here. And you can say, okay, what time of day is it best to take trips? So let me just zoom in on that. So we can see actually, it's actually the best time of day is early morning, right? 3 a.m. People are going to pay. I mean, if you want to stay up at 3 a.m. to make the extra $2 per trip, I'm not sure I would, but that's what we're seeing here from actually what that looks like. And if I just zoom in, we've got some average fare, including tip for each duration bucket. So you can answer that question: is it better for me to take fewer long trips or many short trips? And you can do the math on that. And is it seasonal? Is it affected by weather? And obviously you've got all the cross filtering. So actually, I think I want to take trips then. I think I want to, maybe look at what's the fare looking like there, which location is better. And actually maybe when it's raining. Okay, now I'm down to 126 trips. This is interesting. Let me see the detail of those 126 trips that had an average fare of $10. So now I can right click, if I can, on here, if this will work, and go into my trip detail page. So now this is going against DirectQuery. And you can see already it's quite slow. But this is giving me a table of those individual trips. There's 100 trips. I think it's 100 trips. I might have actually drilled through on something at a higher grain, which I think is going to give me more. But anyway, this loads a map and loads a table. I'm not going to wait for it to load just now. I'll come back to it. But what I wanted to show is, again, where you can even just take this to a different level. So here I've got this idea of scenario modeling. And again, I'm really putting myself in the shoes of these potential taxi drivers to say, well, actually, I've got different options. I've got different scenarios. I can do trips in the middle of the night and then sleep during the day, or I can, or vice versa. So here is saying, okay, well, actually, how many journeys, what county are you going to operate in, mainly? So, Essex, presumably you can't get to all of them. So this is where I live. I'm gonna work there. How many journeys do I think I could do in a day? Let's say 100 journeys a day. I mean, that's a lot. What proportion of those do I think will be a peak time? What proportion of those do I think will be short journeys? So I'm going to do, 80% of my journeys are going to be less than 15 minutes. Nice. And I want to do how many, average, how much does it rain in New York? How many journeys do I think are going to be in rain or heavy rain? And how many do I think are going to be hot? And then what I can see then is actually what my revenue looks like. My total earnings and my revenue looks like over time with those parameters. And if this looks really interesting, I can click on add scenario, use a Power Apps to save it back to the database, and then I've got different scenarios I can compare against. So now I can start to compare, downtown Bronx pickups versus my journeys in Essex. So it's about we're using what if parameters, and I'll do a separate session on this if people want to see this. But, really think about those user journeys. What does the user really want to know? And sometimes it's not just, oh, can I see a history of how well we've done or how many trips have done and what's been the average fare? Okay, yeah, that's good. But how can you take that to the next level? How can you start to really think about the scenarios that you will face there? And let me just go through the slides on this last bit. So start with a high level, take your fields from your aggregation table, and start to look at those fields, those aggregations that make sense. So you can really use those buckets now to make sense. When someone wants to drill down into an individual set of trips, ideally a very small number of trips, then they can drill down and see a map. And I've really not done James's icon map justice here at all. Apologies for that. And you can see a table here with some of the actual individual trips broken down there. So we can then see that detail. And then you consider modeling with the scenarios. Should I summarize quickly and then we can take questions?
Yeah, that sounds good, Rishi.
Sure. So just to summarize, we had 4 main areas that we looked at. The first was start with the end in mind. So this is where you need to really consider your use cases, your insights, and your audience. What do they need to see? And when you're working with this volume of data, you're going to need to display aggregated data and visuals. In fact, you always display aggregated data and visuals. It's the idea of visualization. So think about what you want that aggregation to look like and build a conceptual view of your data model, which then becomes the blueprint for what you need to do in Power Query or in Azure to get to to those tables. Get Azure to do the heavy lifting. Trying to do this all in Power Query is you're going to struggle. So use the enterprise tools for what they're there for. Use Delta Lakehouse for your raw, cleaned, and curated data. Azure pipelines are scalable, so that the data factory pipelines are scalable and they run on Spark. As to mapping data flows, you can use as a low-code option. Again, for someone like me, I really like that option. Leverage enterprise tooling, so use things like Datamarts to have a SQL endpoint, and also put in low-level security logic if you need to. Use aggregations, which allow you to combine import to DirectQuery in the same model and be clever about which one it uses. And consider auto aggregations actually for optimizing DirectQuery. So that's a premium feature. If you've got premium, you might as well just enable it. It's not going to cost you anything more, and it just will speed up some of those queries if you've got the same kind of queries being run. And then lastly, look at those user journeys. Think about how you can start with that high-level view and then allow the user to drill into detail, which is going against DirectQuery. And consider how you can bring the data to life through this kind of what-if scenario modeling. Great. So question time. Sorry for not taking them earlier. I just wanted to get through the material and then we can come back.
Yeah, of course. And don't worry, you could definitely be back with us again. So we do have quite a few questions coming in, so we might as well jump straight into them. So the first one is from Smita, and they've obviously said, thank you for this webinar. It's very useful. Do you have a similar demo with financial data, e.g. stocks, prices, returns, etc.?
Well, I mean, yeah, if for those of you who know me, I love working with financial data. That's one of my other areas, as I mentioned at the start. I haven't done this I've never been able to find a finance data set with billions of rows. Obviously, they exist in large corporates, but I haven't worked with them specifically. And even if I couldn't just take my client's data and do it. So if you have anything, Smita, or if anyone else on the call has a good data set example that we can work with, then one of the things I was actually looking to do is use Azure Synapse database templates, which actually allows you to basically create structures. It's like a common data model, essentially. Like you have predefined structures, and then you map your data into those structures rather than, and they're generic structures defined for each industry. So there's a retail data lake template. So it's called data lake template, I think. There's a retail one, and I think it has about 70, 80 columns which relate to finance, and tables which relate to finance. So it's all budget forecast, it's chart of accounts, it's all of these kind of tables. So what we need to then find is a data set where we can map from there into there and see how that works. So if someone has an idea, let me know.
Excellent. It looks like Andy's Cutler's experience is rubbing off on you, Rishi, and you're slowly becoming a data engineer before our eyes.
No, I'm sticking with Power BI.
Pragati, do you want to go on to the next question?
They're joining together anyway, aren't they? In Microsoft, the teams are the same now, right?
Indeed.
Power BI is the same team.
So the next question we have got from Fernando. So he's saying, like, data in the gold stage in the data lake normally would already include aggregations. So is that right?
Yeah, it contains your aggregations. It's your aggregated data, right? So we have both, right? But I mean, it's the tables that we can bring straight into Power BI without doing any more transformations, right? The idea is that that data in your data warehouse, in your gold layer, should be exactly what you need to put into Power BI. Because the whole point, that's why you're using Azure in the first place. You don't want to do you don't want to work with 2.4 billion rows and do transformations in Power Query.
Thank you.
Excellent. And our next question from Fernando is data. Sorry, not that one. We just had that one. Is again.
Sorry, this is just the one.
No problem at all. So again from Fernando, are you working the target storage in serverless SQL?
Yeah, so it's all serverless SQL. Yeah, so I can show actually how you get to that SQL serverless endpoint if you want. I can show the Datamarts, and then I'll show the SQL serverless, and yeah, I'll take the next question while that's coming. Whilst I'm doing that, I'll try and multitask.
Okay, excellent. Pragati, do you want to go on to the next question?
Yep.
Perfect.
So the next one is again from Fernando. Could you please elaborate on the differences between data lake and a delta lake?
Yeah, sure. So data lake is files stored on data lake. It's any type of file. Obviously, you can have a folder structure to those files, but essentially that's it, right? It's just a folder structure with files in there. And they can be any type of file. There's no schema. You're not defining anything in terms of those files. They're just there. It could be, say, image files or anything in there. And if you then think about data warehouses, they have a very clear schema. right? And it's your data is in a tabular format, and it's you've got all of your kind of transactional history and integrity. I think integrity is a key point to that as well as history, right? You've got your history in there, but you've also got that integrity. So you don't have duplicate records. You don't have your data's. You could go back in time and see exactly what records were. I think that might be a Databricks feature rather than Synapse one. But there's this concept of time travel where you can go back and say, okay, I can see what my data is now. What it says, what I said the 2020 data is right now. Actually, when I initially loaded that data in 2020, what did it look like? Maybe it was different. Maybe that data's been changed. So you've got that concept of time travel. So essentially, Delta Lake is combining that data lake technology with that data warehousing technology and bringing it into one. So you're taking your data lake and you're saying, actually, because it's Parquet files and that schema where I'm going to build a schema around that data lake files, and I'm going to make sure it has that transactional integrity and history built into it, and it gets rid of duplicates or whatever it needs to do to be able to give you that integrity of your data. So that's the real advantage of Delta Lake.
Thanks, Rishi.
Excellent. And the next question comes in from Neelam Mishra, and they ask, when we are adding data through various tables, then we have to have a common unique key to connect multiple tables and only get the filtered data. But what if one of the table does not have the common connecting key? How should I deal with this issue?
Is that just a generic question in terms of coming with a key? So I mean, within let me open up. Let me show this, and then I'll show how we might be able to get keys essentially. Yeah. So this is the wrong one. So in Synapse, I go to Manage, and you can see here we've got built-in database. So say as soon as you create a Synapse Analytics workspace, you have a built-in database, and this is now then our server name. So this is what we need to connect to in say Datamarts or in Power BI directly. Obviously, in our case, we want to use Datamarts as that staging layer. And then in here, we then bring in the data. So let me just go to transform data. So here we have, actually, I did do this actually in here. I probably should have done this in Azure, right? But it was the 1.8 million row table I did this on. But essentially what I did is brought in the table, and I've got my data there, trips ag. Yep. So now I've got all of these. Now what you're saying is actually these need to link into dimensions and should link in by a key rather than by a text field. So I've got those. Right? I created just using enter data. Right. This is just enter data. Yeah. I created my daytime buckets. Right. Early morning, and then the key, the sort order that I want for them. Now I want to bring that key here into here. So here I can create the key, either just enter data, or I can go to add column and add an index column for one, and it will just give me an index. And now I want to bring that key into my fact table. So that's where you can then merge it back in, right? So then you can say merge duration buckets against my duration buckets table. And then I did them all the merges there. And then I just did the expand them out. So to give you temperature category ID, rain category ID, passenger category ID. And then the table I ended up with at the end, or should end up with at the end, is just all in my fact table. It's just key values, integer key values, and my numerical values. And that should be a lot faster than putting the text values into a fact table, especially if it's big. I mean, 1.8 million rows isn't huge, but even then, that's the optimal for those. Yep. So you've got all your keys, geography ID, passenger ID, rain category, temperature. And these are just like 1 to 5 that link back into temperature categories. So very, very low cardinality, very few unique values in here as well.
Excellent, thank you, Rishi.
I'm not sure if that did answer the question. I wasn't sure
if
that
does. It definitely does. And Pragati, are you ready with the next question?
Yeah. So the next question is from Amit. So he's asking, like, will it help having a lot of data in Cosmos DB and serving it in Power BI? So he has a use case where he has a data like around 2 terabytes. So will Cosmos DB help him in this case?
Possibly. I really think it depends. So I'm not an expert in Cosmos DB at all. My understanding is that Cosmos DB is really for it's similar in a sense of like data lake, in a sense of you don't need to define a schema, and actually you can synchronize between Cosmos DB and data lake. Like you can synchronize actually between SQL Server and data lake and Dataverse and data lake. So again, it's almost like a non-schema defined area. My understanding that it's very useful for kind of very, very fast-paced data, right? So where you're bringing in, like, you've got a retail website, and it's got all of that traffic and history and real-time clicks you're putting into Cosmos DB, or gameplay when someone you're actually tracking what buttons people are pressing while playing a game. Really fast moving, really real time on that. That's where Cosmos DB is supposed to be quite good. And then you can query that directly. I haven't done that step in terms of querying Cosmos and putting it into Data Lake or doing things like that, but you could query that, I think, directly from Power BI in DirectQuery, I believe. If you can't do it in DirectQuery, then you can synchronize it with Synapse using Synapse Link, and that's essentially real time. It's very, very near real time, and then you can direct query against the serverless, because that's essentially a way to achieve direct query if the underlying source doesn't have direct query, but you have the Synapse Link.
Cool. Thank you.
Excellent. Thank you, Rishi. And I think we do have quite a lot of questions left, but I'm still conscious of time. So what I'm going to do is narrow it down to a couple of what I think are the key ones.
Okay.
And then we have a couple of requests for you to rejoin us in the future.
Yeah, absolutely. I mean, also, if you just email them to me or something, I can put them up on the community or something like that. I'm happy to answer.
A bit of blogging.
Yeah, I've never been good at blogging, but I am going to start. Actually, this session, I was speaking to Andy Cutler about an hour before the session, and I said, "Do you think I'm covering too much?" And he said, "Well," and he said, "Well, what would you cut out?" And I said, "No, actually, I can't cut it out because it needs to do that end-to-end journey." So I said, "What I'll do, I'll write this as a 4-part blog series. So each of those areas I'll write up as a blog, and that way, if people want to consume it that way, that would be better." So. Yeah, this has inspired me to start my blogging activity again. Benny, sorry, carry on, Liam.
No problem at all. I'll ask another question, and I'll hand over to Pragati for one more question, and then
Sure.
we'll close out. So this question coming in from Laurie. Is it right that instead of using resources of the report server of the company, add in some case when statements and other filtering and transformations, is it recommended to do this through a data lake?
I mean, potentially. It depends where you're going to get better performance. I mean, the mapping data flow I've got here where I'm doing the case statements, I mean, the mapping data flows are fairly quick, right? I mean, I can probably see how long they took, but maybe 10, 15 minutes. In terms of cost, it's not a huge cost to run these. I know obviously I've got MVP credit, so it's easy for me to say that, but yeah, I don't think it's hugely expensive. I think this is still quite efficient. It depends what your data source is. If you can do them in SQL in your underlying source, maybe if you've got SSIS, you've got ETL processes that do it run on that data already, maybe you could just add those aggregation columns at source. I mean, typically as well, the other thing is you don't want to touch those source databases, right? They're usually transactional databases. They've got a particular structure. If you try and go to your IT department and say, I want to add another 10 columns to it, it's not going to go down too well. So actually, you probably are better off just putting it into something like Azure and doing them there.
Excellent. Thank you, Rishi. And then over to you, Pragati.
Yeah, so I think I found this question interesting. That's why I just chose it. So Matt is asking, could you skip Synapse step and use Datamarts with incremental refresh directly on source/staging layer, or would performance implications be too great?
Yeah, I could. So the original version of this demo that I did in 2019, I connected directly to the SQL database, right? And obviously I can do the same thing. I can do aggregations, I can do import mode, I can do direct query. What I will say is that trying to create that 1.8 million row aggregated table failed about 30 times in a data flow before I managed to just get it working. And once I got it working, I copied that data out into Excel and just used that as my source instead, because I just didn't want to go through the pain of that again. But it's possible. It's possible. But trying to do this aggregation on 2.4 billion rows in Power Query is just it's hard.
Thank you, Rishi.
Excellent. Thank you very much, Rishi. I think that's going to be all of our questions for today. So absolutely fantastic session. We do have feedback coming in as well. I'll just stop sharing your screen, Rishi, so you can see some of the feedback as well. So Matt Lakin says, fantastic demo, by the way. Rishab says the scenario modeling looks so interesting.
I'll come back and do a session on that then, actually. Yeah.
Exactly. You just took the words out of the comment. So can you do a separate video on it? Unfortunately, you didn't get out of here flame-free for your icon map. So Anthony did mention this is a poor attempt at an icon map, and James will definitely.
It was a very poor attempt at an icon map. It took me a lot longer to do the Azure stuff than I expected it to. It was, working with that data volume in Synapse. I did ask a few people at Avalon about that, and they were just like, "Why are you using Databricks?" To which I replied, "I don't have the coding skills to use Databricks." So, but I think there is a point there where Databricks is probably a bit more mature with that. I did come across some issues using Synapse, and I think it will get there. I think it just that's ultimately why some of the other things I didn't get a chance to really spend time on.
No, but I think, like I say, very riveting session there, and so many use cases. Just the last comment I wanted to bring up was from Nangu, in terms of financial trading data sets. They say try Quantopian. Potentially, there's something available from that perspective there.
Okay, I'll give that a look, definitely.
Excellent. And the one last point I will make actually is because we do ask across the platforms for feedback throughout on terms of the webinars and topics that you want to hear. We did have an interesting point from Fernando that mentions that it's important to label the difficulty of the sessions. So this type of feedback is really key for you to put into our feedback forms. Okay, so the feedback form is in the chat. So please do take 15 seconds out of your day to let us know A, the topics you want to hear. You asked for Datamarts, we gave it to you. And B, anything that we can do to increase these sessions for you as well.
Yeah, no, that's definitely good feedback. I mean, maybe we should do that in the sessions as well. Just have, when you put them on the flyer, maybe just have a star rating or level 100, 300, 400.
Yeah, definitely. Yeah, I think having that beginner, intermediate, and advanced just works, I think, like the other conferences and groups do. So I think that's really keen because, I think the session which you just gave, Rashid, has got too much into it. And I think it's definitely hard to cover that in a 1 hour slot. So I think that's why people have given that feedback, like it will be great for you to come back with,
Yeah, but I wanted to show it end to end because I think if you just looked at Synapse, if you just looked at aggregations, you lose the context for why you're doing what you're doing.
Yes, exactly.
So that's why at the first section, I actually spent a good 10-15 minutes, talking about conceptual modeling and talking about designing, who's the audience, taxi drivers, what are they interested in? Because actually that's the most important bit. Is if you take one bit away from that session, it's that. Right?
Exactly. Yeah, I think, to be honest, it's the perfect blend in terms of demo, presentation, and then what I think would happen off the back of that, like you say, that end-to-end view, is that certain individuals are going to want a bit of a deep dive over some of the technical aspects, and I think that's where you're going to get the additional sessions off the back of it. But for me, end-to-end,
and that's why I'll do the blog.
Fantastic.
Well, right? Exactly.
Exactly. Well, with that being said, Rishi, we're going to have you back with us. We're going to talk after this in terms of getting some dates in the calendar, because like I say, absolutely amazing end-to-end session there on the power of what I would call the Azure Data Platform as a Service. So absolutely fantastic there. And we're just going to go ahead and close out the show now.
Great. Thanks, everyone.
Hey, Pragati. So again, absolutely fantastic session there from Rishi.
Yeah, I think it was too overwhelming for me, so I may just go back and watch the recording.
Oh, exactly. That's the whole point. That's the whole point and why these sessions are recorded.
Yeah, exactly. So and guys, please go and watch on our YouTube channel. This session is recorded there, so I'm sure many of you might just go and watch it again because there were so many things Rishi wanted to cover in this session. So just go and watch it. We have posted the link in our comments on LinkedIn and YouTube both. So yeah, you can watch the recording there.
Oh, exactly. Go ahead and subscribe to us on YouTube. Please do follow and reach out to Rishi. Like I say, he's an absolute fantastic member of the MVP program, and he has, as you've seen today, an absolute phenomenal wealth of knowledge across the data platform that we can only learn and grow from.
Exactly.
Exactly. So thank you, everybody, for joining us this evening. As always, this Microsoft Power BI UK User Group webinar has been brought to you in association with Pomerol Partners, and you could have been anywhere in the world, but you've been here with us.
Thanks, everyone. Thanks for joining us, and keep sending your feedback to us. Thank you.
Bye-bye.